Guys, so in the last lecture we have seen vapor and liquid dominated power plants. So in today's lecture we are going to see geopressured resources. So what is geopressured resources? So we'll see that, that what is geopressured resources. So before that, so the geothermal fluids, that is hot water and steam, are the resources which are required for generating power. So geopressure resources occur in basin environments. So they occur in basin environments where deeply buried fluid contained in a permeable permeable sedimentary rocks. So so this fluid is contained in permeable sedimentary rocks. So which are warmed means which fluid's temperature has been raised in a normal or enhanced geothermal gradient by their great burial depth. So more is the depth, the more will be the temperature. So the fluids are tightly confined by surrounding impermeable rock. So they are confined by the impermeable rocks. So the reservoir contains moderately high temperature, so around 90 to 200 degrees Celsius. Water or brine under depth are at pressure of 1350 atmosphere. So are found at a depth of 3 to 6 kilometer. So thermal water under high pressure in sand aquifers are target for drilling. So this are target for drilling because it it may contain high high dissolved methane. So a special feature of geopressured water or brine is contained large amount dissolved methane gas. So that is 1.9 to 3.8 meter cube per 1 meter cube of brine or water. So the solubility of methane in water at normal pressure is quite low, but it increases with pressure. So when the water or brine is brought to the surface and its pressure is reduced, so what will happen that this methane gas will be released from the brine. So hence methane can be extracted from brine by simple and economical gravity suppression techniques. So the source of energy available from this type of resource consists of first, so what are the sources of energy? So first is heat energy due to high temperature. Then second is mechanical hydraulic energy due to high pressure. Then the third is the chemical energy, that is due to methane. That is we are obtaining a fossil fuel, that is methane gas, so which we can use for direct energy conversion as a direct energy. So this is the benefit of geopressured resources. So now we will see hot dry rock resources. Hot dry rock, that is HDR resources, or petrogeothermal resources, or petrogeothermal Resources. So, hot dry rock resources are defined as heat stored in rocks within 10 km of the surface from which energy cannot be economically extracted by natural hot water or steam. So, what we can do is that these hot rocks have few pore spaces or fractures. So, therefore, contain a little water and little or no interconnected permeability. So, this the temperature of hot rocks. So, the temperature of hot rocks at useful depths up to 3 km are 150 degrees Celsius to 290 degrees Celsius. So, hot dry rock resources are much more common than hydrothermal resources and more accessible. So, hot dry rock represent highest about 85% of the total extractable geothermal energy deposits energy in the world. So, in order to extract the heat from this hot dry rock, so what we can do is we have experimental projects involving forming an artificial man-made reservoir, artificial man-made reservoir, that is the fractured rock. It is fractured rock. So what we can do is that by if we drill by drilling a deep hole into the hot rocks. So what we'll do this we will drill a big hole in the hot rock. So suppose this is the big hole in the hot rocks and then cracking it to form a cavity or fractures. So we will form a cavity. So this is a cavity by these fractures. So followed by circulating cold water. So then we can follow a cold water and a hot water in this cavity. So by circulating cold water we will get a hot water as output. So by circulating cold water down one well to extract the heat from the rocks and then producing a second well in the closed system. So this system is known as enhanced enhanced geothermal system. Enhanced geothermal system or engineered geothermal system. So EGS, enhanced or engineered geothermal system, and this can be achieved by main three techniques. So what are the three techniques? So first is to create a fracture. To create a fracture produced by underground nuclear explosion or chemical explosion. Then second, to place a high explosive at the bottom of the production well. So to place a high explosive. So create a fracture, put explosive, then fracture produced by high pressure water injected, hydraulic fracturing in the existing fracture. So then we'll produce the fracture by high pressure water injected by injecting high pressure water. So that is hydraulic fracturing into the existing fracture. So these are the three steps that need to be followed to generate this geothermal engineered geothermal system. So now I will draw a block diagram that how it will work. So suppose hot dry rock. So that is HDR. It is hot dry rock. So from here, we will pass water in hot dry rock. So water. So we will get steam as a output. So after, if we get the steam, so we need to separate the steam from the steam separator, because there may be possibility of water content in the steam. So we will pass through a steam separator. So after passing through the steam separator, we will get steam. So that steam will pass through the steam turbine. So we will couple the steam turbine with the generator. So we will get electricity. So we will get electricity. So here, after, we will get water in the steam generator and steam. So water will give back to the hot dry rock, but we need to also supply external water, uh, external water back to the hot dry rock to maintain the circulation of the water. So this is the block diagram of uh, hot dry rock, how we can generate power from HDR. So, so once again I'll explain. So this shows a hot dry rock binary fluid system power plant. So the thermal energy is extracted by pumping water into the crack or fracture. So your water is being pumped to the crack or fracture from the surface and withdrawn by another well at a distance. And injection and production wells are joined to form a circulating loop. So this is created a loop through this man-made reservoir to achieve a steady flow of high temperature water or mixture of water and steam. So heat of water is transferred to second working fluid. So let me draw the uh, power plant diagram. So suppose this is a cavity. So suppose this is the cavity. Oh, wait a second. So here, as you can see, so this is an artificial fracture in the hot dry rock, which is man-made created. So heat. So from here, we are passing the cold brine or cold water to the rock, and we are getting the geothermal fluid, that is hot steam plus liquid, sorry, hot brine, that is geothermal fluid. So what we are doing is just we are extracting the heat from this brine solution and passing its transfer to second working fluid, that may be isobutane. So this may be isobutane, freon, propane, ammonia, etc. So when the heat is extracted, so rocks cool down and causes an unequal cooling and thermal stresses and fractures the rock. So what will happen, that this rock can get cooled down and can have stresses and cool can can fracture the rock. So the size of the original fracture in the hot dry rock increases. So this fracture will increase. The resources keep on expanding. So this will keep on expanding. So as it is getting cold. So only hot dry rock experimental projects were undertaken. So however, these projects have been are currently working in few of the countries also, that is Australia and etc. So we'll see advantages and disadvantages of hot dry rock energy power plant. So advantages, and disadvantages. Advantages and disadvantages of hot dry rock power plant. So we'll start with advantages. So advantages is more number of wells can be drilled into geothermal fluid to obtain a high flow rate, essential for large power plant. So more wells can be drilled. So to obtain a high flow rate, essential for large power plants. Then second advantage is that large geothermal resources can be trapped. So large resources can be trapped. Then third advantage is that water flow rate and temperature may be selected by the different depths of production. So rate and temperature can be selected by different depths. So how much temperature you want, so that much depth you can go. So there is an operational flexibility. So there is a flexibility for the operation. Then fifth, that the life of production well is long. It is about 10 to 30 years. After 10 to 30 years you can generate energy, heat energy from this well. So now we will see disadvantages. So there are several mechanical thermodynamic, metallurgical, and economic studies are required before finalizing the location of the plant. So many studies need to be done. So that is a disadvantage. Second, there is more chances of leakage of injected water from the man-made fracture cavities into the underground layer of the rocks. So there is a possibility of leakages due to the reduction in the temperature in the cavity. So there may be possibility of leakage. So it can move the water into the underground or other cavities. So there may be loss of water. Then third is high cost of drilled wells. So the cost is high and man-made fractures. So to construct this well is costly. So these are the disadvantage of HDR, hot dry rock resources. So then there is another resource also, that is radiogenic resource. So radiogenic resources are found where granitic 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 intrusions are near surface, heating up the local groundwater from decay of, so due to the decay of radioactive material, that is thorium, potassium, uranium, and etc. So this localized heating increases the normal geothermal gradient, providing hot water. So it can provide hot water at an economical drilling depth. And this type of resources are occurs along the US but has not been developed commercially. So this is an also a useful resource, that is radiogenic resources. So this is also a good type of resource for power generation. So these are the main topics which you discussed in geothermal energy. So we will just see in the next lecture, that is what is the geothermal energy scenario in the world and India. So that is what is the potential of this energy in the whole world. So that will give an overall idea of the development of this resource. So hope to see you in the next lecture. Thank you very much.